Hi and welcome to my first Modalys tutorial. Modalys is a physical modeling software that you might know, else you wouldn't be in the niche tutorials of the interwebs. It's by the IRCAM. I have never been to an IRCAM course about that. Years ago, probably 10 years ago, once met somebody called Jean Louchard, who is, as far as I know, working on the Modalys team. But he will not ever remember me. It was like 2 hours in one afternoon that he helped me out with something small. But since then, I have been quite fascinated on and off with this software, and the documentation is quite sparse. It's pretty okay for the Lisp environment, but as soon as it goes towards OpenMusic and especially Max, a part of some examples, some more complex, some less, pretty much on your own. And that's another reason I decided to do these tutorials and to put them in the interwebs on YouTube, because if I lose my way and don't know what's going on, maybe some of you might be able to help. I will be thankful in any case. So let's get started. I will do some examples of the next tutorials about different instruments. So we are going to start simple, like most tutorials start with a plucked string in Modalys, a physical model of a string and how that sounds. Modalys is for free. You can find it here. And this speaks volumes. Well, you can find it on the download page of the forum ircam.fr. IRCAM software. There's tons of cool software here, and it's for free. When you download that package, you also have in that folder the respective folders for all kinds of stuff. So the Max library is inside there, the OpenMusic library, and if you put these folders in there, the libraries they are supposed to be, then you can use them in OpenMusic and Max as well. I will put some bookmarks in the video description, so you can just go over to whatever part you need, because I'm gonna do first the examples in Lisp, then in OpenMusic, and then in Max. I found that, for myself at least, to be the most easy way to go for understanding how all this works. And I'm always going to have this documentation open, especially as long as I'm in Lisp. Today, for the first, we start simple. We do a plucked string. So I drew up a sketch in which you see very well why I became a sound person and not a painter. This is my humble beginnings of trying to draw a string. So that's I'm trying to do it here because that maybe explains better the system which awaits us in Modalys. So in Modalys we create a string as an object, and we create an exciter. Which is basically called a B2 mass, or I'm directly in the objects going to there is also a 1 mass monodirectional, but I'm directly, the 2 mass monodirectional, but I'm directly going to the bidirectional one because we are going to use it in the next tutorial to bow something. And monodirectional means it could only, let's say, move up and down vertically. And for a bow, we need to be able to move it vertically and horizontally. So for pressure and speed back and forth. So I decided to immediately start with that. This B2 mass is basically permitting a little bit more complex interactions with a string. That's why it is that way. So it's basically 2 masses. One is called small mass and one large mass, which are connected through a spring. And you can set different stiffnesses and frequency losses for either one of these 2 masses. So what happens is we create the string, we create this mass, and then we have an axis on the string where we are going to pluck it. And we are going to have an axis on usually the small mass, as far as I saw in the examples, which is then gonna pluck the string. To pluck the string, we are gonna move the large mass. So we are moving this, so we need an axis of this as well, which we are moving, and then the small mass follows, touches the string, plucks it, and lets go, and then the string is swinging. And last but not least, we need another axis where we are sensing the vibration of the string and basically putting our virtual microphone, our listener, to hear something, to hear how the string swings. So how are we going to put this in code? So in Modalys, you create a new buffer, and there is a header you need first. So to comment in Lisp, you do the semicolon header, and it always needs a new. What I like about Lisp is that it only has these rounded brackets, nothing else. And what I sometimes needed for 3D objects, and else it was giving me a bug, was something called in package mlis mlis. That's what I needed. If you want to evaluate, it's Command Y. If you only want to evaluate a selection, it's Command E. Just for you to know, you would anyway see it here. Right. Okay. So let's create the finger, our virtual finger, which is going to be this. To create it, we need to get it a name. Sometimes I see set Q, sometimes I see set F, and I don't remember which way around. I asked a Lisp person to explain the difference. He said that set one of the two can do everything the other does, but not the other way around. But I don't remember which one. So I'm going to go with the example here, set Q. I don't think it makes a huge difference. We give it a name, so my finger. And then we are going to do the make object as it's written here. Make object, then B to mass. I'm gonna leave all the default settings, so I'm just gonna close it immediately. So this is create finger. Next, we're gonna create the string. So it's very similar. Set Q, my string. And we're gonna go here, so you can find it as well, on the bidirectional string or rod. So this one can also vibrate in both directions, so left and right, and or horizontally and vertically. For today, it's only vertically, let's say. So here we are gonna have the make object b string, and you can see all these parameters or properties which you can add, and we're gonna go shortly through those because I like those. So modes means I'm gonna put double 80. Modes means how many overtones are calculated depending on the kind of object it is, the kind of material it is supposed to be, and over the fundamental we give it. So if we pitch it to, let's say, 60 Hertz, how many overtones does it have? So that's the modes. Then we have a length of the string that's in meters. You can also read it in the documentation here what is supposed to be there. Then next we have the tension in newtons, 100. We also have the radius. Next was here the density. So the density is more of a material thing, kilogram per meter cube. So this is 1000. The radius is in meters. So if we put radius 0.001, that's basically a millimeter. And we have a young, and that's an elasticity property. 1 with 9 zeros, that's 1 billion. And then we have the frequency loss, FREQ loss, short, which is basically a low-cut filter, which whoever of you has already dealt with the basics of physical modeling, for example, the Karplus-Strong algorithm, you usually have a low-pass filter because in the real world, our ear is used to high frequencies disappearing faster than low frequencies, and that kind of imitates that effect. And it also creates these transients, which you have once you hit these little extra frequencies you have if you hit or pluck an object, and then these disappear quite fast, and then you have the dampening going on. And the next, so the constant loss is the dampening. So the lower these numbers are, so if it's 0.1, then the longer the high, all the frequencies, also the high ones, are going to sound. The higher it is, the faster it gets dampened. And the constant loss is for the length of the sound itself, so how fast it's dampened. The smaller it is, the longer the sound. The smaller the value, right? Okay. We can also set a pitch. You can see here, we can, in this case, use length, tension, density, or young to change the pitch. So I can set the pitch, my string, to, let's say, tension. And I like low frequencies, 60 Hertz. And it calculates, now it will adapt this tension, it will override the tension for the string to have a fundamental pitch of 60 Hertz. Okay, so that's for these two objects. So if we go back to the sketch now, we need to make all these axes. So one that we move, one that will touch the string, one which defines where the string will be plucked, and then one where we listen to the string. So 4 axes. So make axes. So to make axes, it's also always shown here. And if we go to the B2 mass, we can see it here. Make the axis. We need names for the axes. I'm going to do that. But you can see here, if this my controller value, if this is at 1, that means that the axis is on the small mass. So that's what we want to put in to touch the string. And if it's at 0, it's on the large mass. So that's what we want to move, right? So I'm going to call it that. So I'm going to go set Q, my finger touches. And this is going to make an axis, my finger. And I'm going to put it as a constant value, so const 1. And it's going to only go up and down, so trans 0. I'm not sure trans 0 really, I mean, you just have to, for this example, stick to one of both. Like if it's plucked horizontally or vertically, doesn't really make a difference. You just have to know that depending on what you do, the string only vibrates horizontally or only vibrates vertically. I hope that's understandable. And set Q, my finger moves. So that's what we are moving from this object. So make axis my finger const 0, so that's on the large mass, and we also go trans 0. So we're going to close that. Now we need the 2 other axes on the string. And the string, it's completely irrelevant how many meters long it is. It can be 100 meters. The axis is set between 0 and 1. So this is 0, the start of the string, and 1 is the end of it. That's it. So I'm going to do here set q my string plucked. That's the position of where the string will get plucked. So make axis my string. I'll put here, this would be 0.7, something like that. So 0.7, and also the same dimension, trans 0. And next to it, set q my string listener. So that's where we are putting the listener, where we will get our output. Make axis my string. So let's say at 0.2. That's what I drew here approximately. Trans 0. Oops. There we go. So now the axes are set. All right. Next, we need to make the connections. So we need a connection here so that this can be moved. And we need a connection here between these two so that these two know that they are gonna touch. And there are several kinds of connections, in which way they touch and with which behavior. So if you go here, we can go to connections. We have all these different connections, and to pluck, we are going to use the plug connection. That's pretty self-explanatory. So make connection, connections. So we're gonna, that we don't need actually to name. We can just make the connection. I mean, you can if you really want to. You usually do it if you need to access it from outside. So pluck. So here we need the first axis. So the first axis, the finger that touches. So my finger touches. And there we need to make an initial position. So I'm going to put it at 0.1. That's 10 centimeters, let's say, above the string. Initially, that's where the finger is. And then it will go to my, or it will be connected to my string plucked, which is in relation to it at 0, the position 0. So they're 10 centimeters apart. And we can also put a release control. So I'm going to put a constant 50, which means as much as soon as the pressure on the string is, as far as I understand, is higher than 50 Newton, then the plug connection lets go, and then it releases the string and it can sound. Okay. The second connection we need to make is for the large mass of the fingers. So my finger moves, and we need to move it as well. So first we need to make the connection of, and there we are going to say position, because we want to control its position. So position, we are going to take the position of my finger moves. That's what we are going to do. And then there's a controller, but that's not somewhere we want a static value. We want the finger to move over time. And that's done with the controller. So we go to controllers, to envelope, which is a good choice for this. You can also explore other controllers. So we are going to make inside of that a new controller, make controller envelope. The dimension is 1, which means as much as, like in this example, that in every bracket there are 2 values. So it's just x and y. And so x is the time and y is the value in this case. So I'm going to use the shortcut version to write it. You can also write it like this, but I'm going to use this version of writing it. So we're going to have it 0. So when it starts, the finger will be at position 0.1. You can also take another value, but I find it cleaner if it reflects exactly this value as well. And next, we're going to move it. So after 0.1 seconds, it's going to be at minus 0.1. And that should be enough. I'm closing it up with all the brackets. And that's our connections. And even the finger moving. Now we need just the output. I'm gonna here go to the Modalys workspace. We need this point output. So make output and synthesize there. So we are gonna make point output, and the access reference is my string listener. So my string listener. There we go. Now we need to run it. So the run synthesis is here. We need a duration in seconds. So I'm going to put 3 seconds. And then we need to play the sound. So that's here. Let's just play. There we go. I can evaluate now. And that's my string. That's okay, but I would say it still sounds like shit for all the trouble we went through. And now starts the cool part, because in objects and the properties, the Modalys people some time ago made all these tables years ago, and we can make our, like, let's take a cool material. Let's take uranium. So we are going to make a string. We are going to make a rod. So 19,100 is uranium, and the young of uranium is 2.08 E11. And we're going to make it sound longer, 0.4. And we're going to run it for 6 seconds. Let's see how that sounds. Ah, that's cooler, but still very stringy. Let's make a rod. So let's make it like 10 centimeters thick. And let's say 10 meters long. Ah, that's more interesting. So you can see you can play around with these properties and parameters and find out what you like. And you can also expand these envelopes and make it pluck several times and so on. There are a few helpers here. And if you know Lisp, you can do much more. And if you want to save that, you should just take care that I'm going to save it 01 plucked string. I'm going to save it here, there. And you should save it with .lisp at the end, else Modalisp gets confused. There we go. Okay, so let's move over to OpenMusic. I created a workspace, and I'm gonna make a new patch, which I'm gonna call 01 plucked string. So for those of you who don't know OpenMusic or OM, it's also an Aircom software. It's also for free. It's basically a tool, a visual, it's a bit similar to Max. It's a visual programming tool for algorithmic composition. So you can do all kinds of cool stuff. I've worked with it quite a bit a while ago, but I've forgotten a lot because I went to work more and more with Max, and there is a library in Max which is called Bach, which is very, very powerful, and which actually emulates most of the functions that OpenMusic can do. So I'm over there now. But for if you want to render a sound, especially non-real time, Modalisp and OpenMusic are the safe bet. So we're gonna rebuild exactly what we have here. For that, we need to load this library. So I'm gonna go here, library, libraries, Modalys. I can just double click and it loads the library. I can or just drag it in from here, the B2 mass, the B string, or I can just also, if I want to make an access, mlist access. Yeah. So we need 4 accesses there, and here we need to put some things in. So if you are very controlling, you can, if you put something, if you put something in here, like the constant loss, you can shift click and it will make a new number, and you can type in 0.4 and you can see what's on here. If you don't, you can also just click normally, 0.4. If you hover over these inputs with a command key pressed, you can see what they are, like the properties / parameters. So what we're going to do is we're going to do tension. We are going to put it at 60 Hertz. There. Okay, modes, we're going to put it 80. Length 10. Then here the tension is 100. That's going to be overwritten anyway. The density 19,100. Then here thickness is, or the radius is 0.1. Then here we have 2.08 E11, and frequency loss is at 1, and constant loss is at 0.4. We can already connect that to the axes. It's the second input where we put the axis where we put the object. It's actually written when you draw object. So let's say this and this axis are the one that touch each other. So we need to do them as we have them here. So my finger touches has a constant of 1 and is trans 0. And the my string plucked is 0.7 and is also at trans 0. While the output of the string listener is here, it's 0.2 and is also trans 0, and the part that is moved is here, it's at 0 and also trans 0. So there we have our axes done. Now to connect them, we need a pluck connection, so mlist pluck. There we go. And it's very similarly built, so we need the first axis 1 here, the thing that is plucking. Then the initial position of that, so 0.1, as in our Lisp script. Then the second axis, the original position of that is already at 0, and the breaking point, or what do they call it here? They just call it controller. The release control is 50. It's constant. That's okay. Then we need a mlist. It's called here not position, but position connection. Oh, instead of dragging in, of course, from the, or writing it down, you can always right click and just take all the functions from here. So here we have the Modalys, you have all these, and you can just put them in. So if you have an output, like point output, it will create the object like that, so that we already can connect here. And And here we have the position connection. So I need here the axis, and then I need something to move it. What we had here is the envelope. So I'm going to mean Modalys envelope. And to make an envelope in OpenMusic, there is an OpenMusic object which is called BPF. Breakpoint function is what it stands for. So I can actually just write in exactly that. I will connect it here with a value. That's where it has to go in. And here I'm going to write in, okay, we have 2 points, 0 for the x-axis and 0.1. Close the bracket. And here as a second we have 0.1 and minus 0.1. Close the bracket. And if we evaluate, you can always evaluate with command click, or I guess on Windows control click. It will just give a point. That's because I have to set the value in decimals. That I usually take 3 decimals behind. Oops, 3 there. So now it's more precise. So that's our finger moving down and plucking the string. So now we just need to synthesize. We have everything we need. So there is an object which is called synthesize in the Modalys library, which has these 2 inputs which I don't know what they are for. Maybe somebody can enlighten me. And we need, as we have there, an Modalys new, which you see at the beginning. And to make these new inputs, I press Alt and the right cursor key. Then we connect all this jazz. It doesn't matter in which order. I've tried it in all kinds of orders. It always works as long as you have this new at the beginning. And at the end, you need an Modalys run. And here, as you might have guessed, in this input, we can put the 6 seconds in. And there is an object which is called sound, which we then can connect here, where if we evaluate that with command click on this, it will synthesize. So we have this, and we have this here. So it's exactly the same sound. OpenMusic is done. Good. Now to Max. Max is a little bit different because while OpenMusic and the Modalisp surrounding are concentrated on non-real-time rendering of sounds, where you also can put complex envelopes and controllers on all kinds of parameters and properties. In Max, it's more made to work in real time. And the documentation is even sparser here, I find. It was hard to get my head around it precisely, because there are some examples, but there's always something missing, and there are many objects which don't have a help file and don't have a thorough documentation what attributes they have and which ones they don't have. And due to a lack of autofill, you are pretty much often a little bit on your own and half guessing around. But to do that, what we have here is usually a load bank. So we need to make a Modalys script, which is going to be loaded immediately on start of the patch. And it's going to work a little bit different. What we first have here is the Modalys position object, which should give it a name because we are going to move that in real time, the position of the B2 mass. So name, at name, it's going to be finger position, finger pos, there. This is attached to to the Modalys B2 mass. And I'm gonna call this name my finger, like in the example. So this is now moving the large mass automatically. So the input, as far as I understood, is large mass. The output is the small mass. The output is connected to the Pluck connection. So Modalys Pluck. And I don't remember where I found this out. Maybe in one of the examples I found it, but breaking force, it's called, is 50. I didn't find that name like that anywhere in the documentation. It's called release control in the documentation on Lisp. So why they didn't just call it the same here, I don't know. But let's just work through it. I'm sure they probably have some kind of good reason, right? So the next thing is the string. So B to B string here, name my string. And we can also put in all the all the things here. Here they stay thorough, so it's the same names for the attributes. So modes, we can put in 80, length, we can put in 10. Tension, we can put in 100. Density 19,100. Radius 0.1. Young 208. E11. Frec, oops, add frec loss 1 and add const loss 0.4. And now comes the guesswork. What I managed to find out, I think I saw some presentation of it and I screenshotted the patch. Access, it's called access in initial position. And then this would be the axis where it is getting plucked, so 0.7, and access out initial position 0.2. This works here, right? The console doesn't complain. It complains, luckily, if I put in an attribute which does not work, but it's not complaining in this case, so that's a good sign. And we can also put in pitch parameter tension. Okay. Last, we need the output. So I'm gonna make this here mlist.point output. And what we always need in Max is, with the Modalys, with Modalys library, we always need a script. So all of this is put into a script. I could actually even put in at pitch 60. But what I found out is that if I do that, we will see. Okay, if it works, maybe it will work. Last time I had a bug, and all of that is going into the magic object, which is Modalys tilde. So that's where it's going. Then we just have a live.gain here, and we have an easy DAC there, and we're going to turn it on. So here, please reload your Modalys script. Okay, I'm going to reload. Error, was unable to perform pitch adjustment. Okay, so I'm going to take this away and see if it works then. Yeah, then it works. So if you want to use tension it seems, as a pitch parameter, it seems we have to control the pitch from outside, which makes usually sense if you play it in real time. You don't want to pitch inside here. And if you want to see everything you can control, there is an important message you can send into Modalys tilde. It's control CTRL list. CTRL list. If you attach print object here, you will see a list of everything that you can control from the outside. So usually also these axis out and axis in positions are controlled in most of the examples from outside. I can for some reason put them in here. The same words or the same attribute name does not work for rectangular plate and others. So I don't know why. It's maybe I have in my feeling tried all different combinations of words, but maybe there isn't one, or maybe I just typed wrong. So let's go over the envelope now finally. So what we're gonna use is now the pluck connection, the finger position, finger pause, right? So finger pause position. So we're gonna make a message, finger pause at position $1. So that's where the value is gonna come in. So what we're gonna send in will go through a line, 0 point, so that it's in floating point. And what we had here was that we went from the value 0.1 to minus 0.1 in 100 milliseconds. That's what we did. So now we will be confronted. Oh, we also have to put in the my string at pitch 60, else we're not going to hear anything. Unable to perform pitch adjustment. Okay, so it doesn't work from outside as well. So I'm just going to adapt. It's not going to be the same. Maybe it's a bug, because if I write in length and pitch 60, then it works perfectly fine. No bug. So I don't know what's happening there. But now I can reevaluate the script, press here. And the thing is that it doesn't normalize, so you can't hear anything. You can barely see something moving here, although I'm plucking, because it doesn't normalize in Max. We have to do that ourselves. It normalizes in Lisp and in OpenMusic, but not here. So let's do that. Normalize 0.99, maybe. That's good. Oops, there. Let's put it here. And let's put this here. And now let's play. Yeah, so here we go. Almost the same. Now the pitch parameter is length and not tension, so that's probably why it sounds a bit different to that, right? Well, that's just life, isn't it? So I hope you enjoyed this first tutorial, and see you on the next one.